Thanks, Lars. Hey, everyone. Great to see the energy here, and had a fantastic morning, and I'm sure that all of you did as well. So, yeah, pretty much I'm going to be talking about load testing event-driven serverless backends, as you can see by the slide over there. And yep, I work in Seek. Before you ask, because a lot of people ask me this, no, I can't help you find your next job because that's not my team. I am a software developer, so unfortunately I can't help you find a job. But I'm pretty sure some people who actually work in these teams in Seek, other teams in Seek might actually will. So just getting that out of the way first. But yeah, so just going to give you a bit of the agenda, so pretty much of like how my talk will more or less run. So yeah, giving more or less like an introduction, a little bit of motivation into the more or less like what to expect pretty much, of like why we actually are motivated about serverless backends, and essentially like why we want to load test on them, and how we essentially look to plan into for load testing, how we look to implement for load testing, and do a bit of a demo. Might keep it short because, as you already may know as well, load testing takes quite some time, so I made an abbreviated version of it. And yeah, just more or less give some key takeaways. So before we start, yeah, just a bit more myself again, software engineer at Seek. And yeah, my Twitter or LinkedIn in case you want to follow me and ask me some questions again after the conference as well. Pretty much, yeah, just some fun facts about me. Pretty much, I'm, yeah, as introduced by Lars as well, I'm pretty much quite active within the open source community. Love going to meetups, like run a couple of meetups of my own as well. And yeah, pretty much I've been involved with various activities like running hackathons as well. And yeah, I've been active within giving conferences, talks and conferences and events within for the past, yeah, like 5 to 6 years now. So I've been pretty active in this space already. And yeah, pretty much been quite involved with AWS for some while as well, pretty much. So before we even talk about this slide in particular, the motivation, let me firstly see a show of hands. How many people here have been on call? Well, okay, half the audience, pretty good. And how many people have been on call due to, and we're getting a bit of specific here, due to waking up in the early morning due to your server not being able to handle a particular load? Okay. Fewer hands? Well, if you've covered that, you've covered the exact same thing I did. And that essentially is why oftentimes it is really annoying to wake up at like early in the morning, right? But when you kind of like, especially when you're waking up, not because it's something, you know, like you're supposed to be responsible for, but it's something that you just didn't account for in particular. But that's where it always becomes more interesting, because when companies essentially scale up, they get more customers, they get more traffic, and essentially that's where essentially it all leads into as well, into play. Like you get more nuance essentially with this. You get more troubles essentially in trying to like decide like the scaling. So how do you go about it? And that's essentially going to be the main essence of the talk. So after a pandemic especially, we've seen more workloads than ever shifted into the serverless technologies. And as part of that, determining the optimal loads of a system has always been the biggest challenge that we currently already have as part of this. And so what we really want to do is to be able to identify the bottlenecks, and eventually, so we can identify potential issues later on, so that you don't have to wake up at like 3 a.m. and get a call from someone and yeah, pretty much, you know, wake up to resolve the issue, wake up your family, and that's what we want to prevent essentially from having these kinds of discussions. So let's talk a bit about planning for load testing first to kind of like start off with. So we're getting a bit technical directly out of the gap, but pretty much planning for load testing always pretty much like goes into 8 different stages. So firstly, we start with defining test goals, and after that, we start identifying systems under test. So pretty much as you can see, more or less, is kind of like defining like the what we want to test, and why are we looking to do this? Like, what are we looking to prevent? What are SLIs? What are yeah, essentially, and what are our essentially SLOs? So it's also always part of that. And after that, we also want to identify the systems that will be under test, which essentially, what do we want to test? Which systems are we looking to essentially look to test the load of? And what other dependencies might that system have? And afterwards, talking about how we can design a test plan as well. So how do we want to essentially look into implementing into as part of this test plan? Like, what factors are part of that? What is the architecture we want to look into leveraging as part of this? And like, what are dependencies that come up as part of that? And afterwards, create a testing environment. So how do we want to create this environment? Do we have like a dev environment already in place? Do we have a prod environment? Like, do we want to do it on the prod environment? So it all is pretty much like dependent on this. And after that, we then move on to configuring testing tools. So pretty self-explanatory. After that, we move into like executing the test. And finally, after we already finish that, we then look into analyzing what results we have and optimize from that. So pretty simple, right? Sounds like pretty simple, right? Unfortunately, it isn't that simple because oftentimes when we look into these kinds of backends and the like, there's often always more things happening in the background. I mean, for one, load testing is a very risky thing to talk about like from the beginning anyway, because it's something that oftentimes actually needs to be coordinated with AWS as well, especially when you're looking to working with large ones. So small ones probably like maybe like 50 VUs or like 100 VUs. I'll explain VUs later as well for those who don't know, but it's probably fine. But like when you get to like large load testing, you know, it can be detected like for example as a potential like DDoS attack maybe, and you could get in trouble with the AWS folks. So it's always a very important thing to coordinate this, and it's a very interesting thing pretty much to talk about as well, of like especially when we're looking into kind of like designing these kinds of loads for scale. So what are some questions that we're looking to ask? These are just 5 simple questions, for example, that we're looking when we look into load testing for serverless backends. So for one, how much load can my application withstand? So how much can your application take, essentially? Like, it also depends as well on many factors, like the instance type, your size, and so many factors, essentially. Like, and we can usually monitor a lot of this as well, and like how it's performing as well through stuff like CloudWatch as well on AWS, and yeah, pretty much like around those ends. And aside from that as well, it's like, can my application handle X load? So does your application run well enough in order to handle a particular workload? And does my application scaling work properly? So am I expected to be able to scale accordingly with the number of like EC2s, for example, that are spun up? Or, for example, the number of like Lambda functions that are accordingly adjusting the number of servers that are currently spun up as well. So it all essentially plays into this as well. And how's my application behavior behaving when it has a constantly high load too? So oftentimes, for example, you might, for those who are in e-commerce industry, you already know that, for example, like you have like certain periods of time, like Black Friday and pretty much like all of those kind of times as well when you have extremely high loads within your server. So how does it behave in these kinds of settings? And how can we use history to be able to like deal with this better too? And finally, is my application even working in these kinds of loads? So these are just some potential questions to ask when we're designing these kinds of loads. And that brings me to the testing lifecycle. So as part of this, pretty much, we're looking into 4 main stages. So firstly, we go to initializing the testing lifecycle, which is essentially how we essentially look to initialize the tests. And afterwards, how we look to set it up as well. Like, what are we doing as well to essentially like construct the particular test that we're creating as well, and how we're coding up for the VUs as well, particularly. So how are we pretty much spinning up like the virtual users? So VUs is virtual users. So it's essentially like the number of like workloads that you're essentially spinning up basically to get on board of like essentially like spinning up this traffic, the simulated traffic essentially to pretty much like get people like on board with what you're doing, and yeah, pretty much like to test like how well your application behaves under a certain setting. And finally, to tier down the testing itself pretty much. So we're getting a bit into like a bit of like still technical stuff, pretty much terminology for a bit as well. But it's very important as well to define the difference between metric and a threshold. So within this kind of load testing, oftentimes it's these two are things that we will encounter a lot. So it pretty much is so metrics for one is pretty much like average response time, error rate, concurrent users. So more or less kind of like the KPIs that you particularly use to measure how well your performance is, particularly under a certain environment. So And thresholds are more or less something that we particularly set to be able to ensure that some certain scaling, for example, occurs when we actually have workloads that exceed a particular limit, or essentially actions, for example, trigger like autoscale. So these particular thresholds and metrics work together for us to essentially help us be able to better understand how our workload performs under a certain load, essentially. And when we look into writing performance tests, it particularly goes into three main things, which is basically HTTP request against them being tested. So pretty much it's just more or less kind of like just seeing like how your workload will perform pretty much under a particular HTTP request. And afterwards also understanding as well like how the load configuration you are making will perform as well, particularly within controlling the duration of the tests as well and the virtual users. And I'll talk about that later as well. And particularly within providing the performance goal or the service level objective of what you want to have as well. So what are you promising users? Like, what is the downtime you might have? How do you expect to make it ensure that it is available throughout the entire time, pretty much, and avoid any unnecessary downtimes along the way as well? So we'll start a very simple test script. Now, I won't be getting too deep into too many of the technical coding kind of like wise of things as well, because there is a lot to cover pretty much within load testing. So in this case scenario, I'll be talking about K6. Just a show of hands, like who has heard of or used K6 before for load testing? Oh, quite a few. That's pretty good. So for those who are not familiar with K6, K6 is just another like load testing tool. So maybe people are more familiar, for example, like with artillery, for example, as a load testing tool. Maybe you've been using that more as well compared to like K6. So it's basically another load testing tool. We've used it a lot within Seek, and it's particularly something that we've already used for quite a while within simulating these particular loads. So. And in this case scenario, for example, it is a very simple script. As I mentioned, like there is a lot of terminology and pretty much like concepts with load testing. I'll be just like mentioning a few, but more or less I'll be focusing on the thought process and the architectural thinking after these slides as well. But what I want to do is more or less to get you a bit accustomed more or less to some of the terminology, but eventually get you thinking as well on some patterns that might work for you as a developer, pretty much like within your roles. So, for example, within this test script, for example, we're just spinning up essentially just like using like K6, we're just basically like getting the test, essentially a website, which is like test.k6.io. Now, if you've already worked with K6 for a while, you've already been probably familiar with this. So pretty much what we're doing is just that we are more or less just getting the website, particularly with that HTTP GET request. So pretty simple still. And we then do a bit of a sleep. And afterwards, we start defining a bit of the parameters for a bit. So we start defining some parameters such as, essentially in this case, for example, we're starting to define a duration of, for example, like 2 minutes. We'll spin up 50 VUs basically in 2 minutes time, and we'll keep that test going. And yeah, we'll eventually have it spin up like 50 VUs, and eventually it'll be put to sleep afterwards, essentially. So what it's doing essentially is just basically spinning up a few, of those like VUs in order to like simulate the load. But we could get a bit more technical as well, and then also configure certain stages as well. So in this case scenario, for example, we are pretty much like looking at how we can more or less look into configuring how our workload wants to perform over time. So, for example, we might not expect like 1,000 views to be spun up in like 1 minute, but instead we want to make it more procedural and instead have it spread over a 2-minute duration. So, for example, like spinning up like 200 views in 2 minutes, and after that another 200 again, after that 200 again, and eventually have it decrementally move down 500 at a time in 2 minutes time. So as can be seen, and for example, in K6's terminology, for example, this is more or less referred to with ramping views. So we more or less can essentially move it this way, and more or less also author it a bit this way as well in order to ensure that it is more or less going to scale according to plan. And this helps us as well with more planning for the thresholds and the SLOs that we have as well, particularly. So we can also add more or less thresholds as well eventually, for example, that if we, for example, don't reach a particular response time after a certain amount of time, then we can eventually also more or less get an alarm sent, for example, via CloudWatch or something like that, for example. So pretty much that's like what more or less that is all about. So now let's get a bit into the architecture. And there's so many different ways of thinking about the architecture in terms of load testing. And if you're already doing a bit of load testing as well, you're already familiar with that. There's always the simple load testing, and there's also the distributed kind of like load testing as well. And more or less, that'll depend as well on you understanding the dependencies of your architecture, what connects to what. And oftentimes, this may be like one potential architecture that you may face as well. And for example, in this case scenario, what we're doing is pretty much that we are pretty much pushing up code, having OpenID pretty much like a connect with IAM. But the important thing that I want to turn everyone's attention to in this case scenario is pretty much like what we're doing with GitHub Actions to eventually push into code deploy. Because it is in code deploy where we will eventually run this particular load testing. Because when we deploy the code as well, we can essentially automate these processes to run according to what we want, essentially, and to be able to scale accordingly to the load that we currently have. And basically, with this basic case scenario, that's like what will help us eventually scale up as well. So for example, with the auto-scaling groups that we have as well. And let's dig a bit deeper into what we actually have as part of this architecture. So as you can see, with code deploy, we are pretty much just putting in the code and pretty much just running automation for actually running the load tests. But what happens behind the scenes as well is that we could also have this particular architecture, for example. So let's say, for example, that you have an application that is to get your vendors, particularly, of a certain choice. So maybe e-commerce vendors, maybe your partners, maybe, as part of that your company works with. So as part of this, you then go into as a request, you then send a GET request to get the vendors via the API gateway, and pretty much after that, you then pretty much go into the Lambda function, which then is triggered by that API gateway to go to get vendors, and which then takes into essentially from a vendors table. And accordingly, there could be also error messages set up as well, which is essentially based on SNS email notification or CloudWatch as well. And this is the important thing, because this is where we will eventually test the loads as well. So it's in these kinds of architectures where we try to simulate our loads, try to look if it actually like works well, and see how it performs as well under a lot of stress, essentially. And it is with these architectures as well that we can essentially set up the appropriate countermeasures as well to respond accordingly based on what we currently have. So, as mentioned, pretty much event-driven and more or less quite powerful to set up as a simple architecture. And so this is just a side note as well, particularly. So as part of this, what I'm going to be showing is essentially also a bit of work on CODEBUILD. So particularly what I did is essentially doing a bit of like building up the code itself and like executing the code based on CODEBUILD. So pretty much as part of this, we have like create a YAML file. So for example, as part of this, we are just pretty much like creating just a simple script pretty much to just pull like the K6 image from Docker and have it Docker pull and and eventually we'll run the load test. So pretty simple stuff really. So and we'll see something like this essentially. So when we actually run it on CODEBUILD, for example, we'll eventually see these kinds of load tests eventually like pop up. So as can be seen, for example, in this test, we're spinning up like 500 like VUs, for example, and as I mentioned, like 10 stages with the latter, 5 stages, with the latter 2 being basically just the scaling down of everything. So as can be seen, it's going to be spinning up like incrementally, and eventually, what we want to do as well is that, as mentioned by pretty much by the previous speakers as well, it's always good to pretty much have more, well, automation. I feel like that is the key word as well, because we want to eliminate a lot of manual work, right? Like, I mean, who wants to spin up like instances and load test manually? Like, if you can actually do it like within a certain amount of time, within a certain amount of setting. So when we look into automation, there are so many things that we can also do as well with AWS, particularly to make our process a bit easier. So for example, when we throw event bridges into the mix, for example, we can create a schedule for running at given times, and yeah, be able to like automate the load better as well without we actually needing to intervene in it. So for example, we could set like to run at one time every month, for example, and at a time where we know that users are will not be on. So for example, say 6 a.m., for example, in the morning. So something like that, essentially. And we also can ensure as well a configuration well prepared for this. So when we put EventBridge into the mix, we can see it becoming something like this. So particularly, for example, we use code commit, for example, and use event, which then triggers event bridge, which essentially sends the code, particularly, sends the event, particularly, of running the code build, particularly, so that we actually know that what we're doing is currently scalable. And this also helps us keep in touch as well with what we're doing over time and ensure that with the changes that we've made, we continually assess them and ensure that the servers are continually provisioned just in a way that it is actually scalable according to what we actually want it to be scaled to. So now I'm going to be giving a bit of a demo. It's honestly more of a abbreviated version of a demo because if I actually were to run this kind of thing, like I pretty much like need to run it over quite a while, essentially. Sorry, can't seem to. That's strange. Let me just put it off first and see if I can. OK, yeah, looks like that was in not presentation mode. So what we will eventually see is something like this, essentially. So yeah, pretty much I was originally going to show like a whole like build of the demo, particularly. So in this particular case scenario, just kind of like showing like some of the logs, because yeah, these do end up like taking up quite some time to actually like spin up. But this is just an example of like particularly like how a load test more or less will perform under these circumstances. So pretty much, as can be seen, yeah, pretty much we're deploying it based on this. And the important thing to note as well from this as well is that more often than not, you might actually face some errors as well if your CPU, for example, starts to more or less kind of like show certain signs that it is actually being overloaded or such like that. And more of the times than not, you can actually see this in CloudWatch as well. So pretty much you can actually more or less like tell as well like what are the thresholds that can be exceeded, what have to be like looked at more carefully. So it's essentially just some stuff that more or less is to be looked at particularly. And yeah, as can be seen, it's particularly just a more or less kind of a good way to see like how our resources are being used over time as well. And over time, also see like how it's particularly performing over time. So this is just a copy of one of the builds that I have like particularly made just for testing purposes for this particular showcase. But yeah, essentially pretty much like good to utilize this and pretty much just look at edit from that point of view particularly. But let me switch back to this again. And so some common pitfalls of like what not to do in load testing. So some things to not do are actually not simulate real-world conditions. Well, what a surprise. Well, this is actually a simple thing, but more often than not, oftentimes people work with theoretical kind of more or less conditions, which ends up actually making the loads not efficient and actually not accurate. So oftentimes, this will end up actually being more detrimental than not. And things like improperly configuring test environment, and that's also why as well it's important to read the documentation carefully as well. And not having proper scaling is another big problem as well. And that's why we're performing load testing in the first place. And not monitoring the system during the test as well. Because especially when you first set it up as well, it is very important to monitor it very closely. And as I mentioned in the beginning as well, especially when you're starting to look into the larger scale load testing, it is always very important to coordinate with your AWS support team as well, because, well, like I mentioned again, one wrong move and you could be, it could be considered like a DDoS. So sometimes like there is not really a difference between that if you overload the servers essentially in a way. And of course, not adequately testing the system holistically, because as mentioned, especially with the more complicated your system is, the more potential that there are different points within the system that can actually be down because of what you do. So it's very important to understand the dependencies of what you do and understand how you will eventually address that. So where to from here? Of course, we'll see more of an increased use of automation. We'll see more of use of cloud-based testing, load testing solutions as well. With this, for example, and with different providers like K6, Artillery. We'll see more of an intermingling between this as well. And of course, more use of ML and AI as well to identify potential issues and bottlenecks. Because there's like much more work now that has been used with services such as SageMaker and all of that, as similar services as well within the other clouds as well, to identify these kinds of bottlenecks and identify performances so that you can essentially be recommended better insights as well. So what are some key takeaways? So in terms of ROI, there's definitely a lot of cost savings you can make if you actually scale properly. And of course, aside from that as well, I feel like the ability to be able to sleep from 12 to 8 without waking up from an on-call, I think, is a good enough an ROI, I think, for all of us here. And visualize savings made with AWS Cost Explorer is very good for that. And engage in conversations around impact on scaling, customizability, just some simple stuff as well. Pretty much you can actually vary based on different workloads. I recommend check out like K6's documentation, and what is on a lot of AWS is pretty much like load testing as well. And coordinate testing as well based on AWS representatives though, especially if you're doing large scale testing. And it's very easy to implement. It's pretty straightforward, as can be seen. There are some simple scripts which eventually grow bigger, but it's definitely quite an easy learning curve. And eventually, you can optimize for differing patterns and load tests. So that's all for me. Thank you so much for having me. And yeah, I'll give it back to the team now.